So let's go. So data modeling is rather important in Power BI, even if you're doing self-service BI, like your Excel spreadsheets and building up your models. So tell me if you can see my screen. It should come up now.
Yes, we see it.
Yep. Should be there. Very, very good. So data modeling. Yeah, and it's rather important. So Power BI tries to make it easy for you. And yeah, my introduction is, my name is Markus, and I work with models. And sometimes people have different things in mind when they hear me talking about models. So some think I work with beautiful people, but instead I work with beautiful data. I mean, this model here is special. This one is not so beautiful. It's not really a dimensional modeling, or it's more complex. But yeah, it's not always that we can choose how complex the model ends up to be. And Power BI Desktop is a self-service BI tool. So the first idea of Power BI was to, be a tool, an alternative for Excel users, instead of the building up spreadsheets and then sharing them and then having troubles in manually maintaining them, giving them a better tool in hand, which is not a spreadsheet, because many times we're not using the spreadsheet functionalities that we put in formulas, but we're using the reporting that we build up pivot tables or pivot charts. And with that in mind, the tool tries to make it easy for the end user. So even if you've never heard about the data model, if you never think about that there's a database, or if you don't know that Excel is not a database, like some people don't really realize, then still Power BI should work for you. So Power BI does really a good job in taking away complexity. But sometimes this is what is a good idea, but maybe not good fulfilled, because with that is hiding the complexity, and so you don't know about the complexity. And there could be a point in time where, because the model, you never thought about the model because Power BI took that over, you end up with like wrong numbers or like slow reports. And that's why I want to talk about the data model. So this agenda, we will talk about relationships and denormalizing. I'm not sure if we come to data dimensions, and for sure we will not see any use cases unless in the question section, because I only got 30 minutes and I already lost some of those minutes with my technical troubles here. So relationships. What are relationships? Can you just like mention in the chat, have you ever worked with databases? So who is in here? Have you ever worked with a database that you heard about? Foreign key constraints, Fremdschlüssel in German. Can anybody write something about that? So I know about the audience. If you're not writing anything, I will really explain it at a very low level at the very beginning, assuming that you never heard about this. Okay, either you're shy or really no person heard about relationships so far. I know at least 2 persons or 3 in this call know they worked with databases before. So if you look at the database, then you have those constraints in there. The constraint in database means that limits. So there's a question from Fleming, or you're just pointing out that you work with databases. Please use the chat. I will watch the chat here. So the constraint in the database guarantees that for example, we have a table with all our sales transactions where we refer or mention a customer. And the constraint in the database guarantees that I not put in a customer number which is not available in the customer table. That's the idea of a constraint. It's limiting the things, making the data quality on a better level, because then I cannot put in wrong things, or apparently wrong things. In Power BI, we have a similar thing when we watch the model, that we have the tables and there's a relationship in between, but those are not constraints. Power BI does not care if you put in a customer number in the sales table which not exists in the customer table. Power BI is interested in what you want to filter about. So the idea is not to limiting anything on the sales table, like inserting something, but the idea of a filter relationship in Power BI is, if you select a customer, it will filter the rows in the sales table. So if I say I want to only see one customer, I only see the sales amounts of this customer. Or if I select a country or a year, I only see the country or the year's sales. Or if I put the year in the rows of a table, I only see the sales amount here listed in the same table. That's the idea behind the relationships. So there are similar things. If you're coming from a database environment, you might be confused because this is a different thing. If you never heard about it, easier for you because you only have to think about filtering. And the filter can go in two directions. Either it is a single directed filter. So usually that's what we want to have. You want to see single directed filters in your model. That means if I select a customer, it will filter my sales table. But if I select something in the sales table, it does not necessarily need to filter the customer. So it is only a one way in this filter direction. And then we talk about something which is called cardinality. Don't be afraid. This is an easy thing. The cardinality can be a one-to-many. That's what we are aiming for. Like we usually want to have single-directed filters, and usually we want to have one-to-many relationships. So one customer can potentially have many sales. Hopefully, one customer orders often in our database, and one sales transaction I can directly assign to one single customer. So one sale is assigned to one customer, not multiple customers, and that's why if it is one to many. So many sales can have the same customer, but one customer only can have in one single. One customer can be in many sales. That there's also the one-to-one and the many-to-many, and usually you do not want to have the one-to-one and the many-to-many. I will demonstrate this in a minute, and especially for the many includes also 0 or 1. Of course, if you have a very new customer, which just assigned you as a customer but did not order yet, or is just in the process of ordering, of course, there's no sales amount for this customer available. And after the first order of this customer, of course, there's only one one sales amount entry in the sales table for this one single customer. But still, we speak about one-to-many relationship because it means potentially a customer or the model we built is built for the case that one customer can have many sales. And this is what I want to show in my first demo. Let's go over to Power BI and the different relationships. So what we're seeing here, this is the model view of Power BI, and I have transactions, I have account, and I can put my mouse cursor here to this line in between. Then we see this is a one-to-many relationship. So one account can be mentioned in several transactions. One transaction is assigned to one single account. This is this one-to-many. The reference key is the account ID. So via the account ID, I can identify one account, and I know that this transaction was done for this account because the account ID is mentioned in the transaction table. And that's why we have a one-to-many relationship. So I cannot put multiple, in this case, I cannot put multiple account IDs because there's only one single account ID column here. So I cannot assign this transaction to more than one account. So this is why we end up with this one-to-many relationship. And this triangle here with the pointy end into the direction of transaction means that we have a single filter direction. The account table is filtering the transaction table. If I choose one or many accounts, these account IDs will be taken over to the transaction table and filtering the transaction table. And we can see this in the report. So if I a very easy report here with only those transactions, only those accounts, and we can see that if I select Bill as the account here, number 11, then it will filter my transaction table and only accounts for for account ID 11 appear, or Jeff, or whatever. On the other hand, if I click on one of the transactions here, so I select one single transaction with account ID 11, for example, nothing happens here because the filter direction is only going from the accounts to the transactions, but not the other way around. This is what I mean with the one-to-many relationship and the filter direction. Maybe, Erik, what do you think? If I click here, do you think I'm stupid because I tell you this is not filtering, but then I see that like when I choose 12, we can see only Jeff here. If I click on 11 here, we only see Bill here. So you might think I'm making fun of you, but I'm not. The reason why this filtering happening is not through the model. Power BI has something called cross-filter relationship. So the visuals by default, I can turn this off, but by default, they are also filtering each other. This is not the filter in the model. This is a filter on the visual, on the reports. And this sometimes makes it really hard for me to explain that there is a relationship or not, because people think if I click here, I can see this is filtering there. But this filtering is not done over the model. This is filtering done directly between the visuals. So there's always many things going up happening in Power BI. For the other relationships, so if you think about a one-to-one relationship, this is usually one thing I would avoid, because a one-to-one relationship means one row here has one row at the other side. Maybe there's no row available, so it could be 0 or 1, but usually I have exactly one row in both tables. Then I would try to make one table out of it. So the only reason why I would have two tables is because I want to refresh those tables on different schedules, because the data sources are different maybe. Then it would make sense to have this in different tables. But other than that, you would try to avoid one-to-one relationship. And for the many-to-many relationship, if you go there, the classical many-to-many relationship, put this example. So I have one account, think of a bank account, and then we have customers, think of persons or companies like you or the organization you're working for. And typically, one account can be there could be one or more person with granted rights to account. So the account is assigned to more than one person, like me and my wife, or like all C-level employees in a company on the company account. On the other hand, one person or organization can have several accounts, could have different accounts, like for business and private use cases. So we have a classical many-to-many relationship. And in the classical approach, if you're coming from a database background, you would know and think that we always need a bridge table in this case. And this is what you should model there. So there's the possibility to assign this directly. I could have like a many-to-many relationship inside of Power BI, but this is not the many-to-many relationship we're talking about in this use case. The many-to-many relationship should have been named a weak relationship. So this is more on the slow side, and you should avoid it. If you have a classical many-to-many relationship, then you should come up with a solution like that with the bridge table here in the middle. So this table is a unique list of combinations of account IDs and customer IDs. And as all those are just uniquely available, so one single row has one account ID and one customer ID, they can be referenced in a one-to-many relationship instead of a many-to-many relationship between those two tables. So I end up with a one-to-many relationship on this side and a one-to-many relationship from this side. And this is how you should model the classical many-to-many relationships. Another thing we should talk is how we come up with the tables. So like there's always this question, should I have just one single table or should I have several tables? And I have a slide on that. So let's go to the slide here. Are there any questions, by the way? I'm just interrupting. So second important thing, if you have understood the technical things, that there's filter relationships and there's directions of relationships, then we should think about how we now model the actual data we are having. What I would say the naive approach is to have just one single table. So if you ask me, Markus, please give me a list of products and their subcategories and categories and their sales amounts, I would give you a single table, a single list with a table of 4 columns, product subcategory, product category, and the sales amount. Because it's easy to read, it's easy to understand, I have everything on one. The bad thing with that is redundancy. So if there's one product category with more than one single product, but several products, the name of the product category appears several times on this list. And this is something we want to try to avoid in many use cases, for example, in applications. So if I have an application and I want to store things and you be allowed to change things there, that is application would prefer to having a so-called normalized schema, where I split this up, where I avoid the redundancy. And this is called normalizing. If you've never heard about that, don't worry, it's really easy to do. We try to avoid the redundancy. So we want to have each product category appearing only once. So I come up with an extra table, separate table with the product categories, where I mention the product categories only once. Then I have the subcategories, which are referring the product categories. So there's a key in between, so like a number of this category. And then I have the products referring the subcategories, and therefore over the subcategories referring the categories they are assigned to. And then I would have a sales list with the sales numbers, and then the key to the product table. So this is good from a redundancy perspective, and we speak about third normal form. This would be 3NF or Boyce-Codd normal form, and this is really, really cool for applications to avoid redundancies because they are bad. I need more storage space, but also we have like this anomalies which could happen. For example, if I change in the not normalized schema, if I change the name of a category and I forgot to change one or two of those, I end up with bike and bikes. So we have a typo there, but technically those are two different categories then. We don't want to have that. Or if we introduce a new category without any products, how should we fill this in this one single table approach? Or if you delete things there. So it's more complicated there. Unfortunately, this schema is rather complicated. If you ever wrote SQL statements, then you have to write SQL blah, blah, blah from my sales table, join the product table over the join key, the product ID, joining the product subcategory with the subcategory key, and joining the product category with the category key. So the query is rather long. So it's more complicated to understand and to write, and it's also more complicated for the database because also the database has now to look up all those tables and the keys instead of just querying and filtering some of the rows in one single table. So for querying and business intelligence and reporting and analytics, it's better to have another model which reintroduces some of the redundancy. And this is what I will show you next. And I think this will be the last demo for today. So we have like the single table approach. So the naive way, what I would call, would be a single table in the approach. And I don't mean having one single table as a visual, but I mean that if I go to the field list, that we have only one single table there. So come on. So there's only the factory seller sales and all the attributes of the factory seller sales, the customer, the product, the sales, whatever I need in this model, like for all the date information. So the year and everything is just a column in this one single table. And there are some competitor tools out there, beginning with T. They are optimized for having everything in one single table. They work with that. And as I said, it's easy to understand, but from a perspective of storing the data and querying the data, other things could be more optimized, and definitely Power BI is optimized for not having everything in one single table. Also from a UI perspective, this means I only have one folder in here, one table, so I have to look up everything at one place. There's no structure mentioning what is the product-related attributes, what are the territory-related attributes, what is the calendar. Everything is on one single place. And there's also another backdraft. If I open up, where do I have my Explorer, my file Explorer, then you should be able to see in a second the size of this table. So there is denormalization. And if we take a look there, so how big is this model? Let me see if this is seeable here. The Power BI file is the same, and this is stored. But if you look like on the metadata of the model, this takes up 200 megabytes. If I make out of that a different model, a more denormalized schema, so not one single table, but there's some of the normalizing is introduced, then we will end up with only 80 gigabytes. So this is only a third. And the third means like the memory footprint is smaller, and a third also means that the queries, the querying and the refresh operations are faster. I know everything is compressed into memory, but still, if I have to scan 200 megabytes of memory or only 80 megabytes of memory, of course, 80 megabytes will be faster. So the idea is to having some of the introducing some of the redundancy and denormalizing, but not all of that. And that would be the star schema. If you take a look on this one, I would have one. That's why it's called star schema, because it looks like, I mean, you know, and you need a little bit of fantasy. Yeah? So it could be a three-pointed star. So the fact table means this is the table where all the transactions happening. This is in the center, and all the other attributes we are grouping on or we're filtering on, like where did the sales happening, or when did it happen in the date table, or what did happen, what was sold, like the product or the customer, is just around there. And this is what Power BI is optimized for. So you should always try to have all your data, no matter where it comes from a data warehouse, from a web page, from Excel spreadsheets, or whatever you're connecting to clean this up, to end up with a model view like that. This is sometimes not easy because the data is most often not always delivered in this way. Sometimes you get one single spreadsheet with all the data. Sometimes it's very normalized. So for example, the product table is not just one table, but several tables. And then it is up to you to prepare everything in Power Query. So if I open the Power Query editor, this is the so-called kitchen, where we're preparing everything. So this, I think this term was introduced by Ralph Kimball. If you've never heard about Ralph Kimball, he's the godfather of data warehousing. He wrote the books about the data warehouse toolkit. If you never read one of those books, please check them out. I think he retired in 2012, but his books and website is still out there. So there's free resources on the website, and there's a really brilliant book explaining on use cases how to model your data. And this book is like from the 1990s, but still valid. Still, this is like how to optimize your data model to make it more efficient for querying. And Power BI is exactly built on this technology and optimized for having it dimensional modeling like that. Dimensional modeling means that we distinguish between dimensions, the filters, and the facts. That's what we're aggregating and calculating and counting. And you can always go there, for example, for the product table. As you can see here, in the AdventureWorks, there was no single dimension for the product, but there were two different tables. And what I did here, for example, if you're connecting to a relational data warehouse or relational table, that always at the end, you see like those references to other tables. So if I take a look here, as it was previously. So first we get all the columns, and then we get mentioned all the tables which have a connection to the current table, the dim dimension table, because there's foreign keys and primary keys. There's this constraints available in the database. And so it knows there's a connection between the product table and another table over the dim product subcategory key. And let's zoom in here, and we can always go there, for example, and open this up. So I want to have all the columns from the other table. And that's what I would prefer or recommend. If you have tables where you have your attributes on which you're filtering, always invoke all the other tables. So there's only one single, for example, a product table with all the attributes, including the subcategory and the category information, or whatever you would end up with. So this is like Power Query. You should use Power Query to do exactly that. For the effects, you would just clean up. So if you have effect table containing not only the numbers, the things you want to aggregate, but also attributes, you would also use Power Query to split this up, to make only extract the numbers, and then make a copy of the same thing, but only extract the attributes, and then only show the distinct values and refer to them from the original table. So this is how you would build your dimensional modeling if you not have the luxury of accessing a data warehouse, but have to build this on your own. What about no questions? Everybody's confused, or is it so clear that
there are no questions in the chat?
Yeah, I know. 2 minutes to go. So the question is what I could what could I do not want to start a very new topic on, so let me think what we could talk instead. Normalizing. Do you have in the slides? This is a single table, and then we have again, maybe this is a good reminder to sum it up what I just talked in concrete examples in Power BI. What are dimensions and facts? So dimensions is answering questions like how did something happen, what happened, when did it happen, where did it happen, who, why. Those are the things we are usually filtering on with slicers, with cross slicers, or we grouping inside of visuals. So we have like one row per region and one column per year to make up a matrix or something like that. Those tables are usually small. I mean, it's always relative what is small or not. But compared to your fact tables, your transactional data, the dimensions are small, and they are on the one side of the relationship. They have a primary key and a lot of attributes. This could be text or whatever. I would even prefer text. So if there's, for example, a column saying is new customer or not, true or false, make it a text. Yeah? Make it new customer or old customer or existing customer. So you should avoid confusing things. You always should up with things which are easily understandable by your end users. And the facts, on the other hand, would be everything we want to measure. So we want to count how many sales did we have, like in quantity or in US dollars or euros, or in how many transactions were in this specific period by this customer over this product. So this is the things we're aggregating on, and they are compared to the dimensions usually rather big, because hopefully we're selling a lot of stuff, a lot of transactions, and they're on the many side, and they have foreign keys, references to the dimensions. So there's a customer key in there, or there's a date key in there, or a territory key, or a product key, and a lot of only numeric values, because we want to aggregate a lot of things. There should be no attributes in there, like a name or something. That should be in the dimensions. And with that said, I'm just ready to 30. So let's go to the very end. I will share the whole slide deck. So if you want to look at it, yeah, there's the SQL Saturday in January, of course, shameless plug in. We are currently working on the schedule. Will be a virtual, so everybody can attend. And are there more questions? I will be around for the upcoming break if there's any questions now.